The broadcast is now starting. All attendees are in listen-only mode.
Hey everyone, good afternoon. We're just going to give it a minute for everyone just to join and then we'll get started. All right, well, welcome everyone. We have a big crowd today, which is really exciting to see. I hope you're all doing well, and I'm sure everyone has exciting big Memorial Day weekend plans with lots of travel and getting together. I'm joking. I hope everyone's staying safe and relatively sane out there. We're really excited to kick off today's webinar, number 6 in our online learning series focused on water efficiency. In case I haven't introduced myself yet, or you haven't heard the sound of my voice before, I'm Eli Levine with the U.S. Department of Energy. I have the privilege of leading our Better Plants program. Next slide. So as I mentioned, this is the 6th and final in our initial series for the Better Plants online learning series. If you've missed any of the previous ones, we've posted them all online, so you can watch the recording online. And should you have any questions or any more information, just reach out to me or my colleagues, and we're happy to answer any questions that any of the online learning series has triggered. We've been really blown away by the participation level and the interest level and how these have taken off. We did a poll at the last one, and the response was really favorable. So I think we're excited to come back with more. As we will note in the future slide, we have a couple of exciting events coming up in the office. We have the Advanced Manufacturing Office Peer Review in a week or two, as well as the Better Buildings, Better Plants Summit. So I think our goal is to let those go by, and then we will launch a new season 2 of the online learning series with all sorts of new topics based upon the input that you guys provided. And by all means, if there's any new topics that you would like to see that we haven't covered yet, or if you have something as a partner that you would like to share, please let us know. We're happy to listen to you and take your feedback and try to accommodate all of your requests. So as I mentioned, the slide indicates upcoming June 8th through 11th is the Better Buildings, Better Plants Summit. We're really excited for this, although it's a shame we can't be together in person. It's a virtual leadership symposium. It's free to register, and you don't have to negotiate any travel budgets or accommodation budgets with your work. Just hop online and join us for these. It should be a really exciting couple of days. You see the link down there to register. I think we're up to 1,400 something, so it's quite a significant number of folks that have registered already. So it should be a great couple of days, but we definitely want our industrial Better Plants family to be there to be with us. So please sign up if you have a chance. Next slide. So with that, I'm excited to introduce Kiran Thiramaran. It's a lovely break from Tom Wenning every week. We're giving him a chance to relax and just take these in. And Kiran, I'm expecting to do a really wonderful job. Kiran's been with the program for 4 years now. He's an expert in water efficiency. He has a portfolio of roughly 15 to 20 partners that he's been working with the whole time, and a lot of his partners are some of the standouts in the program. So whether I give Kiran credit for that or give the partners credit for that, I'm excited. It's great to have Kiran part of the team, and I'm excited to hand it over, Kiran, over to you to teach us all a little bit something about water efficiency.
All right, thank you, Eli. Good afternoon or good morning to everyone, depending on where you are joining us from. Glad you are able to join us today. So as Eli mentioned, so over the last few weeks, we had looked at energy, right? We started off with some of the fundamentals of energy, and then we moved on to take a deeper dive into specific systems. Today, we will pivot a little bit and talk about water and water efficiency in manufacturing. We know water is critical to manufacturing, but water optimization and water efficiency usually doesn't get the time and effort it deserves, right? At least not as much as energy efficiency, and for obvious reasons. So water, in a lot of cases, is relatively cheap, and is really hard to justify water efficiency projects. So today, hopefully, we will try to address this a little bit in our small way. And so the webinar is set up like a primer to manufacturing water efficiency. And being so, we're going to be covering a lot of different topics, from water use in manufacturing to common opportunities, and so on and so forth. And hopefully by the end of it, each one of you will have like some nugget of information that you could take back to your organization. Also, just to be on the safer side and avoid any potential disruptions, I did record the webinar yesterday, and we'll be going through the slides with the recording. But as we go through it, please make use of the chat box in the GoToMeeting dialogue, and to get your questions in, right? So we'll have a question and answer session at the end, and we will get to those questions. With that, I think, Marissa, we can jump in. So water efficiency in manufacturing. As mentioned, we're going to be talking about a lot of different things. As part of this webinar, we're going to be covering key concepts. We're going to be looking at water efficiency opportunities, some of the DOE resources out there. But before we get into all that good stuff, I want to like start off kind of like giving a context to why the Better Plants program and Department of Energy in general is interested in water efficiency, right? And the reason is the interdependency between water and energy. So this water energy nexus, it exists at a national, regional, and also at a facility level, right? So at the facility level, we constantly use energy for water. So to pump water to the point of use, and also for treating the water to the required quality, right? We use energy, and vice versa. We also use water in electricity generation, and so on and so forth. So being aware of this water energy nexus is good. It helps us evaluate our projects better. So kind of like knowing the impact of water efficiency project on energy, or the effect of energy efficiency projects on water, kind of like gives us a holistic approach to evaluating projects. So moving on to giving a quick snapshot on water use in the manufacturing sector across the US. At a high level, US industries use 20 billion gallons a day. That is around 5 to 6% of the US total. 15% of that is consumptive, meaning it is lost as evaporation or goes into the product itself and cannot be reclaimed. A majority of the water is self-supplied, as shown in the pie chart. Only a small percentage, 25% is actually got from the city, right? It's paid for. So digging a little deeper into the self-supplied water and charting it across the US, we see the states with that are more industry intensive have a bigger water footprint, right? So like states like Texas and in the Midwest definitely have a bigger impact on water consumption. And the chart at the bottom kind of like breaks down the water, the self-supplied water use from its source, groundwater to surface water. So having this information is good. Knowing where water is used, how water is used across the US manufacturing. But what would be really useful and interesting from the manufacturer perspective is definitely if we know information on how water is used in specific sectors, right? Unfortunately, we don't have the data for the US, and the closest data that we could refer to is the ones available from Canada. So the Canadian Statistics Bureau does this survey once every 2 years to to know the water used in the manufacturing sectors in Canada. And this slide kind of like gives a snapshot on some of the data that is published. So the one on the top gives us the recirculation percentage as well as the intake and discharge plotted across historic years, and the graphs to the bottom kind of give us a snapshot for each industry, how the intake water is used and how it is treated in the various sectors. Um, this raw data might not be accessible for everyone and might not mean too much in its raw form, but we're going to be coming back to this data set when we're talking about some of the DOE resources that we have built around this data set so that manufacturers could make use of it, right? Moving on to the reasons to look at water efficiency and some of the benefits that it provides manufacturer. So outside of the obvious cost savings to the direct and indirect cost component that comes with it is also the reduction in business risk. So water efficiency kind of reduces the impact a potential disruption to the water supply or an increased government regulation could have on the facility. At the same time, it also improves the reputation of the organization. Again, because water efficiency is closely tied up to sustainability and corporate responsibility. So we know the benefits for water efficiency. How do we go about managing it at our organization and at our facility, right? So in an ideal case, we want the directions to be set up at a corporate level. So there are a few things that one can do at a corporate level to kind of like set the directions right for facilities to implement some of the water management strategies, right? So some of the things that could be set up on a corporate level is establishing water efficiency goals, as well as like a baseline for the water usage in the organization so that it could be tracked over time. At the same time, prioritizing facilities and setting focus areas is something that could be done at a corporate level as well. So the picture on the slide kind of kind of like gives a snapshot of the water stress in the US, and it is picked out of the World Resource Institute's Aqueduct tool. So this is a very simple to use tool that you could pretty much go and put your facilities address in and know what is the water stress in the area, right? And another key feature of the tool is you can also forecast what the water stress is going to be like in that specific area. So based on this, there's a lot of organizations that are setting up priorities for facility and target for specific facilities based on the water stress in the area, and that could be something that could be done at a corporate level as well. So corporate level, it is good to set directions, but the actual actions has to be coming from the facility itself. And so these three steps that we have like laid out can be thought about as a water assessment or three steps to managing water in the facility, right? And we're going to be going through them one by one and exploring these concepts a little bit more in detail. So baselining water usage. What do I mean by water baselining? What I mean is pretty much an end-to-end mapping of water flow in your facility. So right from where you're getting it from your whatever your source may be to how it is getting used in the system, how much water is getting used in specific processes, how much is lost, how much is being recirculated, and how much goes to eventually goes to wastewater treatment and to the discharge, right? So you want to have a good understanding of the end-to-end water flow in your facility. And this involves understanding where water is used, how much water is used, and what its source and discharges are, right? And so this water baselining might be very simple and straightforward if you have a good understanding of where water is used in the facility and you have like good submetering in place to kind of like know how much water is used. but we know that in a real world situation that might not be the might not be the case always, right? And it might not be possible for all the facilities as well. So one of the techniques, sort of like a strategy or a technique that you can use for doing this water baselining, is what we call the water balancing. And it is as simple as it sounds. Pretty much what you want to make sure is the total water being used in the systems, like the sum total of all the water used in the systems, is equal to the total water intake, and at the same time plant water intake also equals to the plant water outflows, right? And when I mean outflows here, I'm not just talking about facility discharges, but also evaporative losses, water that goes through the product, so on and so forth. Um, so when we do this balance, what we find is, like, if there's a huge difference between those two, then we know there are like unknown losses or unknown water uses that we are not accounting for, and then that we could go back into the field and try to investigate and find those. So water balancing gives you a good way to um, construct this water mapping or water baselining. So baselining helps benchmark and set targets. So what it is does. So if you're able to do your baseline of your water consumption in a facility for this year, that kind of like helps you track your water consumption year over year, right? In specific systems, how much water is being used this year versus next year, and that kind of like helps you benchmark against other facilities and also sets like targets for yourself on to see how if you're improving. So the first step to kind of like improving is measuring. So, and baselining provides that first step that is needed to start on your water management efforts. So once you're done with baselining and have a good understanding of how much water is used and where it is being used, the next step is to determining the true cost of water. And let's talk about this a little bit more in depth. I know we like alluded to this concept a little bit, but let's define it. So what I mean by true cost of water, right? So as I mentioned, the total cost of water is not just the direct cost associated with the purchased water and what you pay to your sewer treatment, but all the other indirect cost components that goes into it, like cost associated with treating the water, cost associated with pumping it to its point of use, to any chemicals that is added to it, heating or cooling it, so on and so forth. And this is going to be unique for each facility. So even if you're making the same product in two different facilities, this true cost component is going to be different, because again, your sources of water could be different, and the way you take care of the wastewater treatment and wastewater discharge could be different as well. One other caveat to note here with respect to the true cost of water is, so it is good to kind of like aggregate all these indirect costs to get a sense of how much total money that how many dollars you're actually putting into using the set gallons of water, right? So that is the true cost component. But when you're evaluating projects and trying to identify how much cost savings you will get out of it, then you probably want to reevaluate your true cost component unique for each projects, right? This might sound a little bit complicated at first, but it's pretty straightforward if you think about it. For example, let's say if you have a recirculation project that you're thinking about, then you don't want to include, say, cost associated with pumping the water around, right? Because like because though you will be saving on the volume of water, you are not going to be saving on the pumping energy associated with the project. Or on the other hand, if you take like a leak reduction project, you're fixing a couple of leaks that you found in the system, then probably you're going to be saving on the pumping energy as well as the other cost components associated, as long as you have your pumps can turn down accordingly. All right. So that's with respect to true cost. Now, to kind of like get a sense of the magnitude of the true cost, right? I just have an example of a true cost components broken down for a pulp and paper manufacturer, right? Again, this is for a specific facility. And if you look at here, like the municipal and the sewer cost, the direct cost components is pretty much just like 2% of the total. In this case, of course, they have a lot of different things that you might not come across in your facility, like value of chemicals and product that is like lost in the wastewater stream, as in pulp and paper manufacturing. But some of the other things that uh, do add up to this true cost components quite a bit, like chemical treatment, energy for pumping, third party disposal, so on and so forth, which are pretty typical in a lot of manufacturing. So again, in this graph, they um, closing the loop with respect to the water energy nexus. The embodied energy in water is given by the energy to pump, and also in the heat that is being lost in the water itself going out. So what is true cost? Why is true cost important, right? So one, of course, it reveals the hidden cost associated with the water consumption, quite obvious. Another one is it kind of like helps you identify water use intensive systems versus cost intensive systems, right? And let's take a look at these two pie charts to understand that a little better. So I'm looking at the red pie in the both the pie charts associated with boilers for facility. And if you look at it on the left hand side, this for the source water intake, it says like 13% of the total water used in the facility is used for the boiler, right? So that is based on the gallons. So if you look at the graph to the right, even though it uses just 13% of the water, um, it is associated with almost like 26% of the total cost associated with the water consumption. So and that is why you'll be able to identify which systems you want to like target first to find opportunities, and so on and so forth, because as in this case, boiler probably needs a lot more water treatment before it could be used as a makeup water for boiler, and that kind of like adds up to the true cost component for the boiler water. All right. So coming to the next bit, now that we have our baseline water use, we know how much water is being used and how much it is costing us, then we can effectively identify water efficiency opportunities. Not that we won't be able to identify opportunities without finding true cost. Definitely we'll be able to. But once we, if following these steps, we'll be able to associate the true cost calculated to find the true savings from those projects. Water efficiency opportunities by system. So we're going to be looking at three different systems and the top 5 opportunities in each of them, right? So we're going to be looking at cooling and condensing system, boiler, and process equipment. So the first one I have is the cooling and condensing system. And from the perspective of water consumption, the major component of your cooling and condensing system is going to be your cooling tower. So that's where you add your makeup water into the system itself. So a little bit of fundamentals of the cooling tower before and how water is used before we go into the opportunities itself. So we have warm water coming into the cooling tower, which it kind of like cools down and sends it back to the facility, right? So it like removes the heat coming from the chiller or generated at your process equipment. So the way it does it is, so the warm water coming in gets sprayed on top of the cooling tower, and as it flows down, it comes in contact with air that is coming in the opposite direction, being pulled in through the cooling tower fans. And in this process, the water gets cooled down by the evaporative effect. Another thing that happens as it gets cooled down is the minerals that are there gets solidified and drops down to the cooling tower sump, where it needs to be blown down so that it doesn't get added up. So two things to note here is the blowdown and the evaporation, right? Because the blowdown, in addition to the minerals, also removes water, and of course we have evaporation that loses water as well. So the makeup water that we're going to be adding into the system is going to be the sum total of the water lost through blowdown and evaporation. Another key metric to note while talking about cooling towers is the cycles of concentration, which is the ratio of the makeup volume divided by the blowdown volume. And it kind of gives us indication of the performance of the cooling tower, right? pretty much what it is how many times you're like recycling the water, recirculating the water before essentially throwing it out. So higher the number is better, and five to six cycles of concentration is something that is achievable on a cooling tower. So coming to opportunities, of course, the obvious first one we have is optimizing blowdown, so increasing the cycles of concentration. So some of the ways we can do this, one way is definitely improving the quality of water use. So if we are able to treat the water on the front end, then we could be increasing the cycles of concentrations proportionally. Another way to kind of like increase cycles of concentration, optimize blowdown, is to put in an automated blowdown controls, especially if you're having manual controls being operated on a schedule. An automated control, automated blowdown controls, what it does, it continuously monitors the conductivity level in the tanks and blows down whenever necessary. The second one I have is fixing leaks. Quite obvious, not just for the cooling tower system and the associated piping, but wherever in the facility, as soon as you are able to find it, fixing it is a good practice to have. The third one I have is eliminating single pass cooling. So single pass cooling or once through cooling is essentially when you use water to remove heat in a heat exchanger or from a process, and then pretty much dump it out, right, without recirculating it within the system or through a cooling tower. So this is definitely not an advisable practice, except for in very specific situations where the water comes in contact with the product and you have a contaminated water that cannot be recycled or reused. So the fourth one I have here is again associated with cooling towers. So drift eliminators are kind of like additional panels that you can add on to your cooling towers. Some of them, most modern cooling towers come with these drift eliminators. What they essentially do is they decrease the water droplets from escaping with evaporation, and pretty much like reducing the losses associated with the cooling tower itself. So the last one I have is recycling and reusing opportunities in these cooling and condensing systems. So I just wanted to define these two terms here because again, we'll be coming back to it when we are talking about boilers and process equipments as well. So recycling is when you're able to when you need to treat the water before you could apply it in another application. And reusing is when you can take the water as it is and use it for a different purpose, right? So the pretty much the water stream in our cooling and condensing system is pretty much the cooling tower blowdown, which again has a really high conductivity, right? So it is really it's going to be really tricky trying to reuse that water. Maybe some of the application you will look at is pretty much in landscaping. Some of the plants could take the water directly from blowdown. So reusing might be tricky, but recycling is again definitely an opportunity. But the only thing there to note is the economics, right? Would it be worth chasing the blowdown water and having a water treatment for it to be reused? The next system we're going to be taking a look at is the boilers. And from the perspective of water consumption, this is going to be very similar to your cooling tower system, with the only difference being in the condensate return, right? So with boilers, not all the steam that you send into the plant is returned as condensate, and there is a loss in that as well. And we need to make up for that loss in the makeup water that we add in. So moving to some of the opportunities in the system, the first one is very similar to the cooling towers. It's minimizing blowdown and optimizing the cycles of concentration. And all the points we discussed for the cooling tower also applies for boilers as well in this case. The second one is with respect to increasing condensate return. And this is a big opportunity that exists in your boiler and steam system, right? Because this condensate is not just water loss, but you are also losing
on the water treatment that went into the water, and also the heat energy that's put in to this condensate for in the boiler itself. So it is a expensive resource, and you want to like make sure you return as much of it back to the boiler house. The third one I have is installing a condensing economizer for flue gas. So this is a capital intensive project. What a condensing economizer does is very similar to a typical sensible heat economizer, which just captures the excess heat from flue gases. The condensing economizer takes it one step further and kind of captures the latent heat associated with that as well. And in that process, some of the water vapor is also recovered, saving on water. The fourth one I have is again checking, repairing, and replacing steam traps. So both the third and the fourth opportunities, they are going. The most of the savings is going to be coming from the energy side, but also they have a savings on the water side as well. The last one again is with respect to reusing blowdown and condensate water. Reusing blowdown, the some of the barriers we spoke about for cooling tower blowdown also applies, because again this is going to be high conductivity water. With respect to condensate, definitely the first thing you want to take a look at is making sure you're able to like return it back to the boiler house, right? And in cases when you're not able to do it economically, or there are like logistic barriers to returning it back to the boiler, then you can think about reusing that condensate water for some of your other purposes, right? So again, this is like warm water, so there is some low grade heat available in that as well, so you can think about using it in some of your processes or for your cleaning operations. Set of slides I have is on process water use and finding opportunities in them. So process water use, I'm defining it not just water use for fabrication or processing, but also for cleaning, washing, or rinsing of the products going through your production lines, right? So typically process water is going to be the lion's share of water consumed in your manufacturing process, and hence looking at it is going to be critical for facility level water optimization. Some of the opportunities you can take a look at. The first one I have is process equipment modification. And this could range from simple minor design tweaks that you could make to your equipment, to kind of like a fully blown redesign of your equipment and production lines for water optimization, right? So some of the simple things that you could start thinking about, for example, if you're using water nozzles for cleaning the product coming through, you can think about optimizing the number of nozzles, right? Or maybe using a low flow water nozzle um, to achieve the same amount of cleaning required. Maybe you're using water baths or chemical baths in your production lines through which the product flows through. In those cases, you can see can you like add in extra panels to optimize the splash out and reduce it, is something that you could think about. Again, process equipment is going to be unique to each manufacturing process too. So the way you want to go about it is like think about how water is used in the manufacturing process, what is needed, and come up with like design modifications, right? The second one I have is improved production and operation planning. Again, these could be a set of opportunities that vary across the board in terms of complexity and implementation difficulty. But some of the simple things that you could think through to get started is with respect to how the cleaning is done, cleaning shifts are done, or how the maintenance is done, right? So if again going back to the water and chemical baths, usually the water in those are dumped on a regular basis. So thinking through how that dumping is done, what is the operation process in place, and can you like optimize it, is something that you can think through. In a lot of cases, these things are put in place with mostly production in mind, and just like revisiting them from the perspective of water optimization is a good place to start. Third one I have is installing automated control valves. So these could be made use of for your production lines to make sure the water lines are cut off whenever production is not there or whenever it is not needed, to kind of like take out the component of human error in these equipments. fourth one is specific to washing. So if you have washing operations in your facility, there is a lot of different techniques to conserve water in manufacturing washing operations, um, using like counter current rinsing setups, making sure you're like recycling the water within the different baths before throwing it out. So some of those things can be considered. The last one I have is again coming back to reuse and recycling. And this is going to be recycling and reusing is going to be very impactful from the perspective of process equipment, because again a lot of water is going to be used in these cases, right? So whenever possible you want to reuse the water that is coming out of the production lines into in other ways, um, as deemed fit. So, and in some cases it might not be possible because there might be a lot of contaminants. The water could be coming in contact with the product, and there could be contaminants in the water itself. And even in those cases, though, you could still think about like recycling it. And these will these projects could make sense given the volume of water coming out of your process equipments, and also if you start thinking in terms of the true cost components, right? So those are definitely opportunities that you could look at for process equipment.
So we are at the last leg of our webinar, and I'm going to be talking about some of the DOE resources that are available out there for you to make use of. So I'm going to be going through this one by one. I'm actually going to be talking much in depth into plant water profiler tool and the better plants implant training that we have. But I wanted to start off with the DOE's water management strategy document. So this is a document that was put together by the Better Plants, Better Buildings program, based on the water savings pilot that was run. So a couple of years back, when Better Plants, Better Buildings started the water initiative, we worked with a handful of companies, worked with them closely to find what are the barriers that they are coming across in terms of water management, and what are the best practices that could be shared from them across the industries. And we put together this document as kind of like the lessons learned out of that pilot, pretty much to help partners out to get started on their manufacturing, on water efficiency in manufacturing. So this document is available on the Better Plant Solution Center for you to make use of, and also on the Solution Center are also some of the showcase projects specifically on water that you'll be able to take a look at to see what other manufacturers are doing in this area of water efficiency. The second one I have is the Plant Water Profiler tool, the PWP. So it is a free Excel-based tool developed by the Department of Energy, and it helps like systematically determine the baseline water use and the true cost, right? So the three steps that we spoke about: baselining water usage, finding the true cost, and identifying opportunities. So the plant water profiler tool kind of like goes through all those three steps in a systematic way. It streamlines the data collection required for baselining, and also provides like a good summary of reports and high level recommendations. So I just wanted to take a couple minutes to talk a little bit more in depth about the tool, because I think that will be helpful. And maybe after the call you can like download it, take a look at it, and reach out to us if you have any questions. So the tool is broken down into 10 inputs tabs and a result tab, right? So I have the first 8 input tabs here that I wanted to go through, and I'll get to the 9 and 10 later on. So the first tab is plant information. Provides, you just need to provide the background information for the facility, the address, contact info, some of the systems present in the facility, so on and so forth. So tabs 2, 3, and 4 marked in orange here are to do with the inputs for doing the baselining for your facility, right? So some of the information that you'll be providing on these tabs are associated with water intake and wastewater discharge. So at the facility level, and also at the system level, right? At the system level, what is the water intake into the system, its losses, so on and so forth. So the tool itself has built-in calculators that you could make use of to make an estimate
for system level water usage. So in case you don't have meter data, you can rely on these engineering estimates to do your baselining and water balancing and baselining. So that's tabs 2, 3, and 4. So tabs 5, 6, 7, and 8 marked in green are to do with finding the true cost of water at your facility, right? So some of the inputs that you would be putting into these tabs are, say, the unit cost of water, unit cost of the water, and also unit cost for the water treatment, right? So say if you have an RO process in your facility, what is the cost per treating like 1,000 gallons of water through your RO system? So things like that. Similarly for chemical treatment, so on and so forth. So in addition to giving it these unit cost, you would also allocate how much of the water that you're using in your system, it goes through these water treatment processes and so on and so forth, right? And similarly, you will also be providing pump and motor specifications for it to kind of like calculate those embodied energy associated with pumping and water heating, so on, etc. So once you're done with these inputs, at least on the first 8 tabs, you would pretty much be done with baselining, water use, and true cost. So tabs 9 and 10 are sort of more like checklists that helps you identify water efficiency opportunities, but majority of the results for the tool comes from these 8 tabs. So once you're done with it, you could go to the results tab and take a look at some of the results that are generated and some of the summaries that are associated with baselining the true cost. As I mentioned, there are also a couple of checklists, system-based checklists that are available as part of the tool, and those are available in tabs 9 and 10 that you could make use of. That kind of like helps you get started in kind of like asking the right questions and trying to brainstorm about some of the opportunities that are available out there in your facility. So this slide just gives a snapshot of some of the highlights from the results tab. So the graph on the top talks about the true cost of water, and as you can see, the tool provides for each system, for each process that you have defined, each group, what is the true cost of water being used in these systems, right? And it further breaks it down into its cost components, like for process 1, how much of it is coming from municipal water intake, how much is for water treatment, how much is spent towards wastewater treatment, so on and so forth. And of course, like water intake by system, it provides graphs for that. And similarly, the bottom right kind of like talks about the benchmarking, right? So for each, it does it at a facility level and also on a process level. And it is based on the data that we spoke about from the Canadian manufacturer, right? So tying it back to the data set that we spoke about at the start of the webinar, the tool kind of like has it at the back end as a database, and the data that you input, it kind of like benchmarks it against your facility, against that data set to give you sort of like a quick comparison. So that's the PWP tool and its various features. I would love to like go much in depth into it. Actually, I wanted to see if I'm able to like put together a quick demo, but given our constraints on time, I'm not able to do it, but feel free to take a look at it and reach out to us if you have any questions. So moving on, the next resource I have here is the Better Plants water in-plant training itself. So most of you are Better Plants partners, and you are aware of the in-plant trainings available through the program, right? So that is one of our flagship offerings. So 2.5-day event that we have at your facility, and we cover like various different topics. So one of the newest in-plant trainings that we rolled out, we just rolled it out this year, is the one on water efficiency for manufacturing. And it kind of like covers most of these topics that we spoke about, like water baselining, true cost of water, and identifying opportunities in the system. So just like any other in-plant trainings, the goal for the training is twofold. One, we definitely want to train folks on
finding opportunities in water systems and also doing the baselining and true cost analysis. And at the same time, we are there at your facility, so we want to identify some of those water savings opportunities. So we try to kind of hit both of those things as part of the event. So day one, we go through the exercise of creating the baseline water usage for your facility and identifying the true cost, while the second day and the third day kind of is spent on identifying opportunities, putting a savings number on it, and presenting it to management. So just to give a little bit feel for the implant training process itself, of course, the training itself is over 2.5 days, but we do start uh, the planning process well in advance, a couple months in advance, where we reach out to the facilities and kind of like get a feel for the water using systems in there, try to see what is the data available, understand their water usage, evaluate if we need to put in like data loggers. If so, we install them, collect more data, so on and so forth, before getting everything set up for the training day itself. So even before we rolled it out to all Better Plans partners earlier this year, we piloted the water efficiency implant training with 3 of our partners. So we worked with ArcelorMittal, Owens Corning, and Saint Gobain to host these events at their facility. And this table kind of like gives a snapshot, a high-level overview of these events. And I have kind of like summarize some of the key lessons learned from these events and also working with some of our other partners in some of the upcoming slides as well. So the first point I have here for the lessons learned from the field is specifically with respect to doing the water balance and making use of the PWP tool, right? And that is to group sources of water with similar intake sources and discharge outlets together. And what this does, it simplifies our data collection and our water balancing. So in this example schematic that you see here, so we have a process water lines 1 to 5 that uses RO water, and process lines 6 to 10 that don't, right? And in this case, what we could do is we could group these process lines 1 to 5 together, and similarly for process line 6 to 10, and we could perform data collection or estimation on them together. And this kind of like helps with streamlining our data collection and also for water balancing. So the one caveat here is, of course, we won't have resolution into specific production lines. So, but if you need that kind of information, then obviously you can't group it together. But again, if you're like starting off building these models and water mapping, then definitely you can start simple and build it from there. So the second lesson learned here I have here is, of course, like doing this sort of like an exercise of putting a schematic water flow diagram together, right? So most facilities have their pumping diagram for water flows, but again, it's like very convoluted and it's probably not an effective way to understand your water system or get the message across, right? So putting a schematic, something simple like the one shown, definitely helps in understanding your water flows better. So another one I have here is with respect to the lack of metering and submetering in place for system level water usages. So typically what we find in the field is like a permanent submeter is not in place for system water usage. So one way you could go around it is by using short-term monitoring, like using non-intrusive ultrasonic flow meters to data log system water usages and kind of extrapolate it for annual consumption. One caveat to note here is definitely like ultrasonic flow meters are really good to work with, and they do give like good accurate measurements, but finding the right location for them could be a little tricky. So they have specific criteria that you need to hit for them to work properly. Like they shouldn't be close to your elbow bends, and of course like the water flowing through the tube should be clear, and at the same time fully formed for them to get accurate measurements. So those are things to be that you want to make note of when making use of these equipments. Another lesson learned I have here is with respect to water infiltration and precipitation, and this could really make it difficult to do water balancing. So water infiltration and precipitation associated with rainfalls or infiltration associated with other groundwater sources. So these could get mixed in into your water lines before the discharge or somewhere along the lines, and it could really throw off your water balance, because when you have a water line coming in, for example, say if there's a lot of infiltration right outside process line 1 to 5, right, then it really throws off your numbers that you're calculating at upstream, and it could really make the water balancing difficult to do. So moving along with some of the other lessons from the field that we have. So individual system level discharges could be difficult, and it is much easier, of course, to get water readings on the intake side than the discharges, right? Say, for example, in this case here in the bottom left picture, shows us a hot mill rolling operation. So we have our hot product going in through our product line where water is used to cool it, and we see water being drained off into the lower level of the facility, right? And in this case and probably from there it goes off in through a channel via gravity through the outlet and discharge. So it's going to be hard, and in some cases it could be underground as well, and it could be hard to really get uh, a, a good measurement on it, or even put a meter on it to measure it, because of how the way the water flows are set up, right? And so that could be a, a hiccup that you could come across when trying to measure the discharge flow from individual systems. So the last point I have here is with respect to behavior driven water consumption. Say, for example, like in the case of like open spraying, they could significantly change with shifts, because it's totally going to be dependent on the people using it, and in order to accurately estimate it over a period of time, you need to data log it to make sure you're capturing it across shift and over multiple days so that you get a good average. And just a single time snapshot measurement is not a good measure of behavioral driven water consumption uses. So those are some of the lessons we have learned from working with some of the manufacturing companies. So moving on to the last resource I have from DOEN that I wanted to share with you is with respect to the Diagnostic Equipment Loan Program. So we spoke a lot about data collection and the need for it to kind of like do the baselining and identifying the true cost of water. So some of the tools that we have made use of in the field during our implant trainings, we are making it available for our Better Plans partners to use when we are not having the implant trainings, right? So again, this is like completely free for Better Plans partners to use. It comes with the return label, and we do have some of the equipments that I spoke about, like the ultrasonic flow meters for water flow readings, and we even have the conductivity meter if you wanna like take a look at your cycles of concentration in your boilers and cooling towers and so on and so forth. So yeah, if you're interested, definitely get in touch with us. Your TAMS would also be a great resource to know more about the equipments that are available and how you could make use of this. So with that, we have come to the end of our webinar. I hope it was informative. If there was like any questions, definitely like type it in the comment box, or you can raise your hands digitally.
Thanks, Kieran. So yeah, by all means, everyone use the chat box or raise your hand to indicate a question, and we're happy to take some now.
So I did see a few questions come in with respect to making the presentations available. So the slides, the recording, and also the transcript, so all of them will be uploaded to the Better Plan Solution Center site. So the same link that you used for registering for these webinars, you'll be able to find those files there for you to make use of. So again, feel free to make use of the chat box to put in your questions, or at the same time, you can also digitally raise your hands and we can unmute your lines to take in questions, right? So one of the questions I have here is with respect to cycles of concentration for cooling towers. Is there a good range defined, right? And as we went through it, it's going to be dependent on the water quality going in. So it's going to be dependent on what kind of water treatment you have beforehand. I've seen cooling towers going up to like 6 to 7. So that will be the high range that you can aim for. But again, anywhere in the 4 to 6 range is a good number. And anywhere below, then you really need to think through why it is there, right? It is not that if you have 3, then it's a bad cycles of concentration, as long as you're able to justify why you're having that number, right? But 4 to 6 is a good range to go for. So the follow-up to that was we are having a range of 10 to 11 in South Carolina, and if it could be because of weather conditions. So cycles of concentration is not going to depend on weather condition. It's probably because of the water quality. Again, 10 to 11 seems like to me like a range that boilers usually operate in. If you're actually having a cooling tower that's operating at 10 to 11, then actually it is like really great. It's probably something you have a really good quality of water, and not as long as your conductivity is maintained within the range and you are able to maintain 10 to 11, then that's something great. All right. So another question I have here is, does your tool also model compressor systems with quality of condensate blowdown included? So the PWP tool that we specifically spoke about is kind of like a water footprint tool for your entire facility, right? And as such, it doesn't go into specific systems like say compressors or things like that. But we do have a separate tool for compressors and condensate form and removing condensate from compressors as a part of measure. So it is not part of the PWP module. All right. So we have a few more questions come in. What is a good recovery range for condensate return? So so typical range you would see is like 60 to 80%, right? But we do see even higher condensate return being returned from the boiler. And if the higher you're able to go, the better, right? Even if you're able to, some facilities are able to hit even the high 90s. So anywhere from 60 to 90% is a good number to target. And again, it's completely going to be dependent on the size of your facility, the kind of like processes you have in the facility, because again, remember, some of these steam losses could be associated with the process itself, right? And in those cases, it would probably be not possible to return that set of condensate. So it is going to depend on your size of the facility and the processes that you have over there. All right. I'm also having a couple more questions here that I'll try to get to. But if you need to drop off, I know it is right at the 2 o'clock mark. If you need to drop off, thanks a lot for joining our call. I'll try to hit on some of these last few questions before we wrap up. So are there metric standards established already for different industries? So I'm assuming that question is based on water intensities. So as of now, we don't have like a benchmark metric for different industries, right? Few industries might have their own internal metrics that they use for it. As part of the Better Plants Water Initiative, that's something that we try to do, kind of like have a water metric that we want to track, right? But even in that, there is a flexibility in that. We understand it is going to be dependent on your organization, what metrics you want to track as part of your water performance. So that is the Better Plants program does provide a flexibility for setting up metrics. All right. So one last question before we wrap up is with respect to the PWP tool I have, and if there is like an effort in place to creating PWP tool specific for industries, right? So that is something that we are looking at. So the PWP tool right now we have is very generic in the sense it could be used by all manufacturers and is designed as a holistic tool. But we are working with auto manufacturers and looking at other industries as well to see if the PWP tool can be tailored specific to water consumption in specific facilities and kind of build calculators that are more process specific, right? That for that particular industry to estimate it. So that is something that we are looking at and we are looking to work on in the next couple of months. So yeah, with that, Eli, I wanted to turn it over to you to see if there's like any other final thoughts you had.
Wonderful. No, Kieran, I thought you did an excellent job, and you have Kieran's information there. If you have any questions for Kieran, as well as all my contact information and different ways to contact us, just a reminder that we wish you to sign up for the Better Buildings, Better Plants Summit, which is coming up in a few weeks. I think that if you've liked this content, you'll really like what we're covering at the Better Buildings, Better Plants Summit. And by all means, send us your suggestions for future webinars when we're able to restart the second round of this webinar series. And otherwise, just thank you for all of your participation in these, and just a reminder to stay safe out there as you enjoy this upcoming holiday weekend. So thanks, everyone.